No, no, yeah, no, no, no.
Good day, students. I'm Mark Mendoza. You can call me Sir M. Let's mark up your math skills today. For today's video, I will be discussing about infinite limits. And what is an infinite limit? An infinite limit is a limit in which f of x increases or decreases without bound as x approaches a certain number. This states that the left-hand limit is not equal to the right-hand limit. Therefore, the limit does not exist. In relation to the first statement, if the left-hand limit goes downward infinitely and the right-hand limit goes upward infinitely, or vice versa, then the limit does not exist.
Let us have an example. Let's compute for the limit of the function 2 all over x minus 2 as x approaches 2. Using table of values, we can compute for the left-hand limit and right-hand limit of the given function. To compute for the left-hand limit of the function, we assign x values which are less than 2. Evaluating the function using these x values, the value of f of x becomes smaller and smaller. On the other hand, to compute for the right-hand limit of the function, we assign x values which are greater than 2, and evaluating the limit of the function using these x values, we can see that the value of f of x becomes larger and larger. Now, let's analyze the graph of the function. Analyzing the graph of the function, we can say that the left-hand limit of the function approaches negative infinity, whereas the right-hand limit of the function approaches positive infinity. Since the left-hand limit is not equal to the right-hand limit, therefore, we can say that the limit does not exist. If f of x becomes infinitely large in magnitude, positive or negative, as x approaches the number a from either side, we write the limit of f of x as x approaches a is equal to positive infinity, or the limit of f of x as x approaches a is equal to negative infinity. Let us have an example. Find the limit of 1 over x squared as x approaches 0. Using table of values, we can compute for the left-hand limit and right-hand limit of the given function as x approaches 0. As shown in the table, the values of f of x as x approaches 0 from the left and as x approaches 0 from the right become infinitely large. Let's analyze the graph of the function. As you can see in the graph, the value of f of x becomes infinitely large as x approaches 2. By the limit definition, the limit does not exist since the function does not approach a single number. But in this case, since both the left hand and right hand goes upward infinitely, we can say that the limit is positive infinity.
Therefore, we say that it is not approaching a real number, but it approaches positive infinity. Infinite limits also identify the vertical asymptotes of rational functions. We say that the vertical asymptote of a rational function is at x is equal to a if the one-sided limits are both infinite.
Let's find the vertical asymptote of 2 all over x minus 2 as x approaches 2. Since a is equal to 2, therefore, the vertical asymptote is at x is equal to 2. Just by analyzing the graph of the function, we can actually see that the vertical asymptote is at x is equal to 2. Let's find the vertical asymptote of 1 over x squared as x approaches 0. Since the value of a is equal to 0, therefore, the vertical asymptote is at x is equal to 0. Just by looking at the graph of the function, we can actually see that the vertical asymptote is at x is equal to 0.
And that's it. I hope you learned something today. Watch out for my next video on solving for infinite limits algebraically.
Hey.